All right, good afternoon. I believe it's time for us to get started. Thanks everyone for sticking around to the last session of this year's TechEd Europe. So at least I know that you all really care about network management in Virtual Machine Manager. So thanks for sticking it out till the end. So before I get started, I'm Greg Kazanza. I'm a program manager on the VMM team in System Center. Was anyone here for my session this morning on Zero to Cluster to Cloud? Besides Eric. All right, I just want to show you real quick. I promised to show what it would look like when the host finished the deployment. There it is, a successful deployment. And there it is in my host group. So I can just drag that and add it to the cluster just by selecting credentials. Skip the validation. And that'll get added now in a few minutes. Just wanted to do that real quick. All right, let's get started with networking, because that's why everyone is here today. I'm going to be talking about networking in Virtual Machine Manager 2012 Service Pack 1. It's actually a really important session this year because there's a lot of change going on in the networking space right now. I like to think of it as being the dawn of a new era in that what used to be defined solely in the physical layers of the network is now starting to move up into the software layer in much the same way that when virtualization of servers started, a while back, what used to run on physical servers moved into a virtualized environment, and you got a lot more flexibility, and a lot of change happened as we moved towards virtualization of servers. A similar thing is happening now with virtualization of networking. We call it software-defined network, and it's kind of the trend that the networking industry is going in these days. So you're seeing the start of it with Windows Server 2012, and I'll show you today how we're starting to take advantage of that in VMM 2012 Service Pack 1. So in order to prepare you for that, I'm going to be talking about some of the things that, first of all, what we did in VMM 2012, some of the new concepts that we introduced around logical networking, since that will still apply as we move forward to Service Pack 1. But really, 2012 laid the foundation for that, for how we modeled the network in your data center. And then the majority of this session is going to talk about what's coming up in VMM 2012 Service Pack 1, because I think that's what you're all here for, to understand how we're taking advantage of the new capabilities of Windows Server. So starting with VMM 2012, what were some of the scenarios that we wanted to target when we first started planning that release? We went out and we talked to customers, and the first thing we heard is, customers want their VMs to connect to a particular network. And when they describe what network they want to connect to, they say they want to connect to the corp network. They don't say, have any of you heard your customers say, I want to connect to VLAN 5, or I want to connect to VLAN 50? No, you want a certain connectivity that you know by name. And so to model that, we introduced this concept called logical networks. Basically what it is a logical abstraction of the underlying physical infrastructure of your network, so that when you connect your VM, you're not connecting it to a particular VLAN and subnet. You're connecting it to the logical entity that you want that VM to be able to connect to. And then same thing, when you have other VMs connect to that same logical network, they'll be able to talk to each other. So next thing we heard is customers want to be able to create a VM template that they can deploy anywhere, regardless of what the networking is defined in the site that they are deploying it to. So for example, in building 42, you may have you may have a different subnet, different VLAN than what's in building 25. Yet they're still considered part of the corp network, right? Your corporate network, it spans multiple buildings, but in each location, in each site that you may have different settings that exist underneath. So for that, we introduced a concept called logical network definitions that define what your network is like for a particular site, so that as you have a logical network, it can now span multiple sites because they're all connected by this logical network definition. Another thing we heard, customers want to be able to assign IP addresses to their VMs. They don't want to have to type it in themselves. How many of you have used Excel for tracking your IP address utilization? Yep, quite a few hands. So yeah, we heard people use Excel, other somewhat messy methods for tracking IP addresses. So we introduced a concept called IP address pools that basically lets us have these IP pools and keep track of the address and assign them to VMs as needed. And then finally, when we started to add our service model, we introduced this concept of being able to scale out a service or a tier of a service. Now, when you start to scale out, it means you're creating multiple VMs that serve the same function. But of course, each of those VMs is going to have a different IP address. So in order to be able to access them, you need to have a virtual IP in front of that. And for that, we need to have load balancer support in the product. So we went through in 2012, and we basically added support for all of these capabilities. Logical networks, they let you classify your network. It's an abstraction of what lies underneath. Your address pools, not just IP address pools, but MAC address pools and virtual IP address pools for your load balancers. And then load balancer support. So I'll be talking about each of these in a fair amount of detail over the first part of my deck. So let's talk about these objects, how they relate together. Starting with the logical network. That, again, is like your container for your corporate network. Within that, you can now have many logical network definitions. So essentially each site that you have in your environment can have its own logical network definition that you can create. And that is essentially defined, and that gets assigned to a host group. So you can say that your production environment has access to this, or is being implemented in this building 42 for logical network definition for 42. And then for each of those logical network definitions, you can say, so what is the actual subnet VLAN that backs it? And you can actually have multiple subnet VLANs. As you need more space, you may allocate a new VLAN in a particular environment. So we allow you to define multiple of those for each logical network definition. And then finally, once we know what your subnets are, then we can have the concept of the IP pool, where we actually say, here's a range of addresses that's available for your VMs. And of course, you need to map all that to a physical adapter so that we know what the connectivity of the actual host is that exists in your data center. Because not every host may be connected to every VLAN, for example, even though it's in a data center or it's in a site within your network that has that VLAN available. So you have to be able to still pick which VLANs, which logical networks that physical host is connected to. And then finally, in order to get connectivity all the way to the VM, we have to be able to map it to your virtual network adapter through a virtual switch. So that kind of shows the relationships of all the objects. Address pools, I talked about these at the beginning. Basically we have three basic types of address pools. IP pool is your basic. We have a range. We have all the settings that go along with being able to allocate that address, such as your DNS servers, your gateway, WIN servers. And we basically, whenever a VM gets created and you say you want a static address, we'll pull an address out of the pool that's available, assign it to that VM, and as long as that VM exists within the VMM server or on a Hyper-V host that's managed by VMM, we'll keep that checked out to that VM. And so we prevent it from getting assigned multiple times. MAC pool, similar concept, but for MAC addresses. Again, we assign them, and then when the VM gets deleted, we put them back. And then virtual IP pools, we keep track of the virtual IP that represents the single point of entry for your service. And then we have all the dynamic IPs that exist behind it that virtual IP maps to. Those get assigned to the clouds and are available for use by your services. Of course, in order to be able to use those virtual IPs, we have support for load balancers. There are 3 partners today that we have providers for that we're able to integrate with to provide load balancer support. F5 has their big IP, Brocade, and Citrix. And then in the box, we have support for the Microsoft NLB load balancer as well. That gets installed automatically when you install the product. Basically, the idea is you install a provider from the third party, you add the load balancer device, and then you create your virtual IP templates that get then used by the services as you create your service. So let's go through and show you some of these concepts in action, so we're not doing slides all day. So I'm going to switch over to my demo environment and bring up my VMM server. So this VMM server is running a version of VMM 2012 Service Pack 1. I'm going to start off by showing you the concepts that exist in 2012, and I'll mention the areas that are new in Service Pack 1. I'll be talking about those more in detail in a minute. But the first thing I'm going to do is I'm going to go down here to the networking section. You can see I have a number of logical networks that already exist. We've discovered some of these automatically. The Contoso and Corp network we discovered from the network adapter. There are actually some settings in the settings section that you can use to control that discovery. If you go to General and Network Settings, you can see here's where we determine which logical networks we'll discover automatically. We did that because we heard feedback from a lot of our customers that there were a number of steps that they had to go through after they installed the product, and they didn't want to have to do all those initial steps before they could deploy a VM. So we added this network discovery process where we try to figure out what your logical network is before you do it manually. You can turn that off, of course, if you don't want it, or you can control how we identify what those logical networks are. So I'll just cancel out of that. I'm going to go, you can always still go and create your logical networks manually if you want. I'm going to go do that now. So creating a logical network is as simple as giving it a name. I'm going to call this TechEd. These settings down below here where we define where we select whether or not the logical network is connected or not, or whether or not we're going to use network virtualization are new in Service Pack 1. In 2012, we go into this assumption that we have this requirement actually, that every network site within a logical network is connected and equivalent. So that if you deploy a VM onto VLAN that ends up with VLAN 5, and you deploy another VM that ends up with VLAN 6, but they're both part of the same logical network, we require that the network on the back end has those VLANs connected and are routable so that those VMs can talk to each other. Now, in 2012 Service Pack 1, we're adding this new option that says, no, they are not connected. And so I'll be talking about what you can do with that and why we did that. So I'm going to start with a connected logical network. And now I'm going to define my network site. So each site can now have a separate set of VLANs and IP address subnets that it uses. Now, this information will ultimately need to come from the network administrator that sets these up. So the server admin will go to the network administrator and say, I'm setting up this new data center, and I need, this many IP addresses, and the network admin will come back and say, here are your subnets, here are your VLANs, and then the server admin will enter that in. So I'm going to go ahead and do another one. So let's say my network admin also gave me this VLAN 4 that I can use as well, and my network administrator set everything up behind the scenes to connect them. And then I'm also defining for my other host group that I have another VLAN and subnet for that. So with that, I've now created a logical network that defines 2 network sites, each one scoped to different host groups. So now when I deploy a VM to rack 1, it'll get the settings for that site. And if I deploy a VM to my infra host group, it'll get the network settings that are defined for the other site, so that each part of your building that has its own network settings will get the right settings automatically when they get deployed. Now, last thing I have to do before I can use it, though, is I have to create an IP pool. I'm going to call this my TechEd IP. Here's the logical network I just created. If you didn't create your network sites in advance, you can create one now. I already did that. You specify the range that's within the subnet. You can say which addresses are reserved for VIPs, or you can reserve additional addresses. For example, I'm going to reserve my gateway so that doesn't get reallocated. And then I'm actually going to specify the gateway here. Let's see, 1.1. And I'll go ahead and finish it. I'm not going to specify DNS right now. These are your standard IP address settings. So there we go. And you have a logical network. We have multiple network sites defined, and we have an IP pool available. Now, one other thing about IP pools is they are needed only for static IP address assignment. If you are using DHCP in your environment, you actually don't need to have the IP pool. You can let DHCP server assign from its own pools. That's also supported as well. So the last step we need to do now is go and actually indicate which hosts now within that host group are connected to that logical network, and which adapter on those hosts is connected to it. Because generally within your host, your Hyper-V host, you'll have multiple adapters, and each adapter may have a different type of connectivity. You may have one that's used purely for management on the back end. You may have another one that's used for just your VM to VM traffic. So you have to actually go into the host and map which logical networks that host is connected to. So I'm going to add TechEd here to my host number 1. Now when I deploy a VM, which I'll do in a little bit, our placement algorithm, and I say that this VM needs to have TechEd connectivity, our intelligent placement algorithm will now go through, find the hosts that have that connectivity, and it'll find HV-H01 for that. So that's logical networks. Let's take a quick look at MAC address pools. So you can see we create 2 default pools automatically. These are the standard ranges for VMware and Hyper-V. You can create additional ones if you want as well, and scope those to particular host groups. So I go create MAC pool, give it a name. It's going to be my building 42, MAC address pool. I'm going to say it's for rack 01. And then I can give it a range, which I'm going to copy and paste. Typing it is no fun. And I'll just say FF. So now I've just created a new MAC address pool, and that one's now available for use by the VMs in that environment. Quick question?
Regarding the logical networks and the network pools, does this work for VMware hosts that are managed through VMM as well?
Yes. Yes, it does.
Okay, because it's just affecting the operation.
Right, exactly. So really ultimately what it comes down to is which VLAN do we set on the VNIC and which IP address do we assign to the VM? And really, how do we customize the guest OS? And how does our placement algorithm then determine which nodes, which hosts are available for deployment? Okay. You have a question in the back? Oh, thank you. The question was, does it also apply to VMware as well, the concept of logical networks and everything that I just showed you? And the answer is yes, it does. All right. So there's MAC address pools. So moving on. Next, we have load balancers. Let's add a load balancer to our environment real quick, because that's usually one of the next things you'll want to do once you have your basic networking set up. Now you want to make some your self-service users want to be able to deploy services on the back end. So you can see we have the NLB load balancer installed by default. I'm going to add an additional one. I have an F5 big IP ready to go. Now I've already gone ahead, and before I do this, I've already gone ahead and installed the provider that I received from F5. You would get this from your vendor of your load balancer. And if you go down to configuration providers, you can see what's currently installed. Here's my F5 networks provider. So I ran the installer, and it did all the setup automatically. But now I need to actually add the device that I want to use with VMM. So I'm going to go down to load balancers, select my run as account. You have to have credentials. Run as account is our container for credentials. I've created these in advance. And I'm going to say which host groups this load balancer is available for. If you have multiple providers, you can select which provider you want. And then you give the connection info for your load balancer itself. And what port it's connected on. And then you have to say which of the logical networks that you have provides your front-end connectivity. That's the connectivity that provides the virtual IP addresses, and then the back end, which is where the dynamic IP addresses come from. So I'm going to select Contoso for the front end, and then I can now select my TechEd network for the back end, for example. And then one last thing we have here before we finish is we have a test page. So you can actually test to see if your credentials and your provider and your device actually work. So we go out and we actually call each of the functions that are available in our provider, and we show you the results. Test results all pass. So now we know that this load balancer, we've been able to communicate to it. Now we deploy a service, and we need to configure that load balancer to provide the virtual IPs for that service. It should work. I'm going to go ahead and finish. And now I have my big IP load balancer ready to use. Now, before I can actually use it in service, I have to create a VIP template. This essentially defines the virtual IP, the behavior of the virtual IP that the load balancer will configure. So you go here to create VIP template. I give it a name. I would call this, say, for my web server, which port you want for the virtual IP port. What type, so you can have a generic or one that's specific to a particular load balancer. If it's generic, you have fewer options because it basically has to take the least common denominator of settings. So if you have multiple load balancers, in different host groups, but you still want to use the same template over and over again, you can do that. But if you have only one type of load balancer in your environment, you can do a specific option. I'm going to say this is going to be doing HTTPS. You have a number of different protocols available. Settings as far as persistence go. How you want the load balancing to take place. If you want to do least number of connections round robin, those are also available as well. And of course, there are a number of health monitors that are available. Those depend on the provider as well. All right, so I'm finished. So you can create basically as many VIP templates as you want, and then later on, when you create your clouds, you can now assign those to be available to your self-service users as you see fit. All right, so let's switch back over. to show you a little bit about how you would do some of this through PowerShell. What you see here can be generated from our UI. We have a View Script button that you can click on after you go through the wizards and generate basically this exact same PowerShell that I have here. So that would be your best way for how you can get this same PowerShell. And that's how I generated this, actually. Basically, the first thing we do is you create your logical network. We're doing new SC logical network. That essentially creates the container of the logical network. Once you have the container, now you can start to add host groups that it'll get associated with. Here I'm adding host and infra in this example. And then you can add your subnet VLANs. Again, this corresponds pretty closely to what was in our UI. And once you've defined those, then you can create the logical network definition, give it a name, and then say you assign it to your logical network and specifying your host groups and your subnet VLANs. And then once you have your logical network definition created, you can now create your IP address pools. So you can define your gateway using whatever address you have for your gateway. And then define your DNS settings, your WIN servers, all of the settings that are available on the IP pool can be defined and passed in. It's simply a new SC static IP address pool commandlet. And then one more thing that's useful is if you actually want to determine what the utilization of your IP address pools are, generally we don't feel that customers will need to see each individual IP address in our UI, but we do make it available through PowerShell if you need to know where is every address assigned. You can get the SC static IP address pool, and then you can get the specific IP addresses from that pool. And we have an option that's called -assign, and it'll return all of the assigned addresses. In this case here, we're showing which ones are assigned and which ones are also unassigned. Unassigned can happen if, for example, you remove a host that has VMs. We'll mark them in an unassigned state, but still allocated. And the reason for that is because we don't know what the state of those VMs are anymore. The addresses may still be in use. The host may be using some. So to be safe, we don't unassign them if we don't know for certain that that VM is gone. If you delete a VM from our UI, we will automatically return that address to the pool because we know for a fact that that VM has been deleted. All right, so now I think we're all here mostly to hear about Service Pack 1. So everything that I told you is essentially the foundation for what we're doing in Service Pack 1. And there are a number of networking scenarios that we want to target in Service Pack 1. In particular, we've broken up those scenarios into the concepts of connectivity, so basically which VMs can talk to each other, and capability. What can those VMs, once they can talk to each other, what can they actually do with that connection? And separating them is very important because it means that you don't need to duplicate the capabilities for every type of connectivity you have. You can define your capabilities and reuse them over and over again. So it really limits the number of objects that you have to maintain and keep in your environment. So connectivity, to us, it means the ability to have multi-tenancy. So you can have multiple tenants in your environment, all sharing the same physical network. The ability to have them isolated. So if you have multiple tenants, they generally you don't want them to talk to be able to access each other's VMs and machines. We give you additional mobility options. When we introduce the concept of network virtualization, now your VMs are not tied to the physical infrastructure anymore as far as they know. They can move around within their virtual space. And then also with network virtualization, we have the ability to bring your own IP into a hosted environment. So you can bring on-premise address space into a hosted environment as well. Now for capability, now you can have the ability to find quality of service on your connection. You have a number of security options available, and I'll be talking about these in more detail as we go along. You can optimize the connection to find how much bandwidth you get on a particular connection, and then you can monitor as well with the right kinds of extensions. So in order to provide these scenarios, for connectivity, we've introduced a new concept called a VM network. And the VM network essentially defines the connectivity for a group of VMs. And for capabilities, we're introducing a concept called a logical switch. And this is really the central point that defines the capabilities that you're going to have in your environment. So I'm going to go through each of these in more detail. First, connectivity. So connectivity, it all centers around VM networks. With multi-tenancy now, the VM networks will have an owner, much like many of the other shared objects in VMM, like a VM template has an owner, and then it gets assigned and is shareable to multiple user roles. The tenant admin will be able to create their own VM networks if they're given that revocable action. So you now have the concept of a tenant that's able to create their own networks without actually even going to the network administrator. When you have tenants now, those tenants will likely want to be isolated. So we have this concept of isolation, whether or not you're going to have isolation on that network. And there are a number of different methods we provide for doing that isolation. Even if you want no isolation, you want a direct pass-through to the Fabric infrastructure, we provide that as well. Bring your own IP. This is largely enabled by the new network virtualization concepts that are provided by Windows Server 2012. The idea is that the VM address space or the customer address space is now virtualized on top of your provider address space. So you can bring whatever you want into the virtualized environment, regardless of what the actual data center is using underneath for its own address space. And then finally, mobility. Since we're connecting the VNICs now to VM networks and only to VM networks, now these VMs can move anywhere that VM network is available. And when you introduce a concept such as network virtualization on top of your fabric, that virtualized network can span multiple subnets underneath it, whereas while your virtualized space stays consistent across all those. So you can move the VMs across your data center subnets, but still have the same subnet within the guest within the VM. So let's talk about each of the different types of VM networks, as far as how we provide this capability. So the first one I want to talk about is no isolation, and this one is really just a pass-through to your logical network. The idea is that when you do an upgrade, you'll have a number of VMs that have existing connections to logical networks, and you want those to continue to work before you have to actually go in and make changes. So on an upgrade, we'll automatically create a VM network for every logical network that you have in your system. And those VM networks will be of type no isolation. It gives them a direct pass-through to the logical network. The other scenario is for management tools. Sometimes System Center itself or other management tools will need to get access directly to the hosts and to your fabric. So that's the other scenario around no isolation. It gives you direct access to your fabric. Generally, the administrators will be the only ones that own these no isolation networks. They'll be the only ones that have access to no isolation networks. So that's primarily what they're for. If you look at what the object model looks like behind these, so this is a portion of the diagram I showed you at the beginning. I'm going to be reusing this throughout each of the different types of VM networks. The no isolation VM network points directly at the logical network. There's no additional subnets defined, no additional IP pools. So the next type of VM network is based on Hyper-V network virtualization. And before I start talking about the VM networks, let's talk a little bit about the technology that runs behind them. So if you recall at the beginning, I talked about how server virtualization was a shift in how servers existed. They went from physical to virtual. And it allowed you to run multiple servers on a single piece of hardware. The servers were abstracted from the hardware, and you could actually share a single server among multiple tenants. Network virtualization provides the same concept, but now for networking. You can have multiple tenants sharing the same network, each one with their own virtual IP space that can move around regardless of what the actual provider of that network is. Now, how does that work, though? Because now each tenant can essentially have the same IP address space that overlaps because they are completely isolated from each other. So you can have blue tenant has 10.0.0.5, and so does red tenant. Same thing with your 10.0.0.7. Your data center network, they can all exist on your data center network, even on the same machines. So if you have 10.0.0.5, both on the same machine, both VMs on there, how's that going to happen? Well, what happens is the host itself has an address from the provider network that exists in your data center. This is your traditional network. And VMM, as the management tool, it creates a table of mapping for every tenant. What does the virtual address, how does it map to the provider address, or the customer address to the provider address? And once we know that policy, we can then set it on each host so that if Blue 1, for example, at 10.0.0.5, wants to send a packet to 10.0.0.7 or Blue 2, when it gets sent from the VM, it goes into the host. The host has what's called the Windows Network Virtualization filter on it. And as that packet leaves the host, it goes through that filter. And that filter takes this policy that says that, and sees that this packet wants to go to 10.0.0.7, and it wraps it in a packet called an NVGRE packet. This NVGRE packet has the physical routing information on it, so it says that its destination is 192.168.4.22. So now this packet can get sent using your normal routers, using your normal data center network across to 192.168.4.2, or host 2. And when it gets there, host 2 unwraps that NVGRE packet. It sees inside the real destination is for blue 10.0.0.7, and then it knows that it sends it to this VM. That's what the Windows Network Virtualization filter does. So that's essentially how Hyper-V network virtualization works. So we have another type of VM network now that exposes that. And we set by default the encapsulation using NVGRE. There's another method called rewrite, where the packets simply get rewritten as they enter and leave the host. But we think that the industry is going towards NVGRE, so we default to that. And essentially what these VM networks define for Hyper-V network virtualization is each VM network represents a routing domain for a tenant. And within a routing domain, you can have multiple subnets, and you can route in between them, much like what we had for logical networks, where you could route between your subnets. Within your routing domain in a VM network with Hyper-V network virtualization, you have a similar concept, but it's all virtualized. If you look at the objects that we had defined for logical network, well, your VM network still points to the logical network, so you have to have a provider address space that lets you route on your network infrastructure. But then for the VMs, each VM network gets its own VM subnets defined and its own virtualized IP pool available. So you actually have, a provider address space and a customer address space. And the VM only sees the customer address space. Now, if you have these isolated networks, at some point, the traffic, you're going to want to get the traffic out of those VM networks. So for that, on a physical network, on a traditional network, you'd have a gateway device. Well, you have a similar concept for Hyper-V network virtualization, where you have a Hyper-V network virtualization gateway. And this is, again, the same type of device or similar device. And it basically receives the policy updates from VMM so that it knows, that these customer addresses, how to route them outside of the virtualized environment. There are two basic scenarios that we support or will support with these network virtualization gateways. The routing gateway for a private cloud scenario is essentially where you're routing directly from network virtualization environment to your physical address space. It's for if everything is running entirely on-premise and you're just simply moving your physical address spaces into a virtualized environment to give you more flexibility on your data center. The other type of VPN we're going to support is called a VPN gateway, and it's for a hosted scenario. So basically, if you're a hoster and you want to offer network virtualization, your customers can bring their on-premise IP address space into the hosted environment, and through the VPN gateway, they can establish a site-to-site VPN tunnel that will route between their virtualized network in the hoster back to their on-premise network using the same address space that they have on-premise. If we look at a little bit about how each of these work, for the routing gateway, you'll have your VM network with your virtual subnets, and those will get routed through a single gateway device directly to your physical network. The VPN gateway, it's a very similar concept. You still have the same VM network, you have your data center network, but this time you have two gateways. The one that's managed by VMM as the network virtualization gateway, and then your traditional, site-to-site VPN endpoint that you might have on-premise. And that's what gives you the link across the internet from your virtualized environment to your on-premise environment. All right, so two other types of VM networks that we support. We also support VLAN-based networks, so a lot of you today are using, yes, a question. In CDP2, we do not have inbox gateway support yet. So what you will need to do is you'll need to use the Hyper-V PowerShell to configure a gateway manually. Now, for all your hosts. So you will have a number of steps. We're working on the gateways, but they're not available in CDP2 yet. Okay, so VLAN networks, most of you today are using VLANs for your isolation. And we think that people will continue to use VLANs for a fair amount of time to come. So we have support for VM networks based on VLANs as well. Basically, the idea is that you assign one VLAN per VM network, and you're using the VLANs now for isolation. Now, this requires you to coordinate with your network administrator to make sure that they allocate the VLANs, because you're going to have to, because the switches have to be configured to keep those VLANs isolated. But you can enter those in and define those within VMM and now use VLANs for isolation. This is where that property that you saw very early on in my session comes into play, my not connected property. Basically, you'll need to say that the logical network is not connected. So we know that we won't use it like a traditional logical network. We know that the VLANs are isolated, so you can create a VM network on top of it. If you look at the layout of the objects, we basically reuse a lot of what's in the physical infrastructure, but map it now to a VM network. And then you get to pick a subnet from your logical network definition that actually goes into the VM subnet. And then you use the pool, since VLANs are based on your physical infrastructure, we take that information from your physical infrastructure. Then the last type of VM network we are adding is called an external VM network. So this is where we come in, where the Hyper-V extensible switch comes into play, and it has switch extensions that run within the switch. These switch extensions can implement their own type of isolation that exists at the switch port level. And this isolation is really transparent to VMM, or it's actually VMM doesn't know how the isolation is implemented. So we just get a report back from the switch extension that we have these isolated networks available, and we let you connect your VMs to them. So for that, we get from the switch extension, we get this VM network, type external. We have a subnet that comes from the VM network, that comes from the switch extension, and then we have an IP pool that comes from the switch extension as well. And so we can allocate addresses for these VMs, but everything gets implemented by the switch extension itself. I'll show you those in action in a little bit. So let's create a VM network now. Go back to my demo machine. All right, so here is the same VMM server that you saw before. And if we go to logical networks, you can see that I have this logical network already created called my Fabricam NVGRE network. And if you look at the properties, I've actually checked off to say enable network virtualization. That's the only thing I've done with this logical network that's different from the one that I created initially in my earlier demo. As I said, I want to be able to use network virtualization on this network. The network site is a very simple network site. There aren't even any VLANs defined. Yet with network virtualization now, I can actually go and create a VM network on top of that without involving my network admin at all. So I'm going to go now to my VMs and services view. And we have this new section called VM networks. And there's a pivot up top where you can see all your VM networks that exist. Now you can see I have a number that are already created. I have pass-throughs to go directly to my logical networks. These are the no isolation types. And then I have 2 that are defined of type network virtualization. If I look at the properties, I can see that they're based on the Fabricam NVGRE network. So I'm going to go ahead and create a new one now. Let's say I have a new tenant that comes in, and I want to create a VM network for this tenant. Let's say this tenant is called AdventureWorks. And I'm going to put that on the same logical network that my other tenants are on. This network is set aside for my NVGRE traffic. So now, based on the type of VM network and what the setting, or based on the settings on the logical network now, the wizard now gives you what options are available for isolation on that logical network. In this case, my only 2 options are isolate using Hyper-V network virtualization or no isolation. So I'm going to say use Hyper-V network virtualization. And now I can define my subnets. I'm going to call this my AW subnet 1. And I'm going to give it the address space that I want for that subnet. And I can create multiple subnets. I can start off with 1, and then as I want to move more into my virtualized environment, I can create additional ones. And when I create multiple subnets, within the Hyper-V network virtualization, there's actually a Hyper-V network virtualization router that actually handles automatically behind the scenes the routing between these multiple subnets. So I don't actually have to go out to my router and configure them for the subnets. Hyper-V network virtualization takes care of that for me. Okay. I'm going to go ahead and finish that. So now I've created my, my VM network for AdventureWorks. Now I'm going to do the last step of creating an IP pool. Yes, question. So the routing, you can't disable the routing, but you can, within the guest, say that you don't want to use that gateway. So the .1 address of your subnet always becomes the gateway within your virtualized subnet. And so, if you tell that VM to not use the gateway, then you're not going to get any routing. But the routing is always there. If you want no routing, then just create one subnet, and there will be no routing that takes place. Is there a reason why you'd want the routing disabled? Yeah, so if you don't want the routing, really the right answer is to create multiple VM subnets, with each subnet basically being its own VM network. Or create multiple VM networks with each one with one subnet, and then they're completely isolated. The idea behind the VM network is that everything within there is connected to each other, so that's why you need the routing. Okay, so I'll go ahead and finish the IP pool, and you can see here that the .1 address was reserved for the built-in router. And then you have all the same basic options that you had for your regular logical network IP pools. So that IP pool is now created, so now I can actually go and use that on a VM. If I go to one of my VMs here that's up and running, I have a number from a number of existing clients. I can go and create a new VM. And I can actually select to use that VM network. Let's call this TechEd. Go down to my network. And you can see now that I have my VM networks available. Here's my AdventureWorks VM, or my AdventureWorks VM network. I can select it and go through and finish it. And now this will get is deployable on any location where the logical network that backs it is available. Cancel that. All right, so let's move on. Yes, go ahead. Mm-hmm. So each one of these VM networks has essentially a routing domain behind it. That routing domain is what identifies the network as being essentially a unique, isolated environment. We are adding a concept of a tenant admin, though, that's essentially a user role that will let you have each tenant its own. You will have a tenant admin concept that represents the tenant. All right, so this is just a little bit of the PowerShell behind the VM networks. You can see it's very very similar to what we had before, except now the concepts are now dealing with VM networks rather than logical networks. So you create a VM network as your container. You define your subnet VLANs for your VM network. You define your VM subnet. And you define your static IP address pool in the exact same way as before. Except now you assign it to the VM network instead of the logical network. All right, so that's connectivity. That's talking about VM networks. Now let's talk about capability. So once you have these VMs now that are connected to each other, they're isolated, how do you go about defining capabilities on that? Yeah, one more question before I go on. Yes. So on every Hyper-V host that knows about that VM network, reserves that address for the router. So it always knows that within that routing domain, the .1 address is always the router. There isn't one router that exists in a single place. It's a virtual router, essentially. and every host knows how to handle it. All right, so let's talk about capabilities. Oh, the question was, let me just repeat it, was how does the Hyper-V host know about that router and where does it actually exist, essentially? Okay, capabilities. So once you have the ability, you have connected VMs, how do you define what those VMs can actually do on these networks? What are some of the settings that you can apply and make available? Well, we have quality of service. These are things such as how much bandwidth does this VM need as a minimum. We have settings for security, whether or not that VM is going to be able to have a DHCP server, for example, or things like that. And then we have the ability to do monitoring. When you have a switch extension that's able to look at the packets that go into the switch, you can actually monitor to see what those packets contain and actually do traffic analysis on them. All these capabilities are provided by the Hyper-V extensible switch. It has a number of native capabilities in the box, and then many more capabilities will be available through extensions that are added into the switch. And one of the key things is those extensions are added. They're extending the existing capabilities of the switch. They're not replacing the existing capabilities of the switch. They get plugged in, they get added, they get removed, and they are first-class citizens. And they go through a logo certification, so they should be of very high quality as well. There are a number of different types of extensions. They basically live in the switch. But every machine has its own set of extensions, and they all have their own set of configurations. Because of that, you need some tool, management tool such as VMM, that's able to go in and on each host set what those extensions are that are available in the switch, and configure them for each of the VMs that use them. You can see here the basic types of extensions that are available. You have capture extensions. These are extensions that basically capture the traffic and do traffic analysis on it for reporting, for chargeback, that sort of thing. There are filtering extensions. These are extensions that will look at the packets and actually add or remove packets or modify packets. You could have a virus detection extension that will block packets that contain viruses, for example. And then finally, you have forwarding extensions. These are extensions such as the Cisco Nexus 1000V that actually define their own forwarding rules for how the packets are going to get sent from VM to VM. And so you have those types of extensions as well. All of these need to be manageable by VMM. In order to do that, we have to have a pluggable interface into VMM that lets us talk to the network management database that these extensions provide from each vendor. If you look at how that works, you have a number of components involved in that. You have the VM server itself. You have the vendor's network management console, which has generally a policy database that says what types of capabilities are available on the ports for that extension. And you have the Hyper-V host itself that's going to actually get the extension installed and get configured to use it. So what we do is we have a provider interface similar to what we have for load balancers that vendors are implementing providers for that will let us talk to these network management consoles. And basically, we'll go out and query these consoles to pull in information about the network. Now, we're not just getting information about the switch extension itself, because these network management consoles can also contain a whole variety of additional information as well, such as what logical networks exist, what IP pools, and even what VM networks do you have out there if you are using your external isolation. This is where these VM networks come from. So we can import all that, and that reduces a lot of the possibility for errors along the way. So if you saw at the very beginning of my session, I created my logical network manually and typed in my VLANs and my subnets manually. We can now have the ability to import all that information directly from the network management tool through these extension manager providers. So it greatly reduces the possibility for errors, and it also allows the network admin to create additional network objects later on, automatically get them imported into the VMM server. So once we've imported this information from the network management console, we can now actually go and start to configure the Hyper-V host to use it. So we can set the port profiles on the individual ports for the VMs, and then that switch extension knows how to go talk to the vendor's network management console and then go and retrieve the actual policy that backs that profile. And then VM will then get that policy and will be able to get that set of capabilities. So if we actually look at what this looks like on the Windows Server 2012 host, you can see you have a number of extensions. Each extension has its own set of settings, its own set of capabilities. The switch itself also has a number of settings. And then you'll have a number of VMs on there, a number of host VNICs, and a number of uplinks. The uplinks are the connections between your virtual switch and the physical adapter that are in the host and basically connecting you to the outside network. Now, if you multiply that times all the hosts you have in your system, that can actually get pretty complicated very fast. As every host has its own set of extensions, its own set of settings, how do you manage that in a consistent way across all these hosts? Well, in order to do that, we're introducing this concept called a logical switch. And this logical switch gives you a central place where you can define what extensions are going to get used and what are the settings for those extensions. You define them once and then apply them to as many hosts as you want in your environment. You don't need to go out and configure them individually on the hosts. You don't need to worry about them being different on each host. We'll go out and apply those settings as appropriate and as you define them in the logical switch. So it's a single logical representation of your virtual switch. And it gets applied. You can think of it a little bit like a template that's used to create the virtual switch instance. So a little bit about the objects and how they relate to each other for the logical switch. You have the central logical switch object that represents the switch that exists in your the logical representation of the switch that exists in a particular part of your data center. In this case, building 42 switch. You optionally can select which switch extensions you want to use with that logical switch. In this example, we have the Cisco Nexus 1000 and the Inmon S-Flow. These are optional. You can use the capabilities of the logical switch and the native switch capabilities without using any extensions whatsoever. Next, you need to define how are the uplinks going to behave for this switch. Now, you remember that every port, whether it's uplink or virtual, has a group of extensions that can work on it, and then it also has native settings. We have to configure all of these on every port. So in order to group all these settings together, we have this concept of an uplink port profile set. This basically is the set of configurations for each extension that you have and your native settings all lumped together so that you can just select all those settings together as a single entity. On the virtual side of things, we have a similar concept of a virtual port profile set as well. But in between, we have this concept of a port classification. Now, if you remember earlier on, one of the things that we heard from our customers, they want to be able to create templates that span across their data center that they can deploy anywhere. But if your switch uses your Cisco technology, you use Cisco technology in one part of your data center, and you use some other technology in another part of your data center, you have to have a way to abstract that out. So we introduced the concept of a port classification that is what your VMs actually will connect to. So you expose the port classification to a cloud and say this cloud supports the FastDB, the web, or the restricted classification. And then your self-service users will connect their VMs to those classifications rather than to the port profile set, which maps to your fabric infrastructure. So if you look at this, the only thing that self-service user sees is the classification. So you're now able to create a template that's able to span multiple logical switches, essentially, or be deployed on multiple logical switches. And then finally, once you have your switch defined, you have to be able to actually map it now to a physical NIC. So for each physical NIC, you can connect it to a logical switch, and then you select an uplink port profile set to define how that physical NIC is going to behave, what settings it's going to get on that switch port. If you have no extensions installed, this is essentially what your network model looks like for your logical switch. Okay, so let's actually see what it looks like from our UI. I'm going to switch back over. And I'm going to switch to another VMM server where I have this set up. Okay, so you can see here, I'm actually connected to I have a Cisco Nexus 1000V set up. Here I have a terminal session to it. I can show you some of the objects that I have defined in that Nexus 1000B. I can do show fabric network. You can see I have this Contoso FN defined. So this is essentially my logical network that I've defined within my Nexus 1000. I also have logical network definitions. Well, actually, I have one network definition defined that goes with As part of my Contoso FN, I have my external LND. And then I also have a VM network defined as well. So if I were the network admin, I would have gone into my Nexus 1000 and defined these. But now as the server admin, I want to make these objects available to my VMM users. So I do that by going into my VMM server, and we have this new section for switch extension managers. Now, I've already gone and added the provider for the Nexus 1000, as well as the provider for my SFlow, which is another type of extension that I'm using that does monitoring and traffic analysis. I'm going to go back to my fabric, and I'm going to add my Nexus 1000V to the environment. Before I do that, I just want to show you logical networks. I just have the two that got created by default automatically. OK, so let's add my Nexus 1000. So I'm going to add a virtual switch extension manager. I select the provider in a very similar way to how I did with the load balancer, and then I give it my connection string. So we'll copy and paste. And of course, you always need credentials, which I've pre-created in this run as account. And then I say which host groups I want this Nexus 1000 to be available on. And as soon as I finish that, you can see I've added this as switch extension manager. We're going to go out and we're going to query that extension manager, or that Nexus 1000, and find out what's there. And you can see that now we have this Contoso fabric network that my network admin defined, and I automatically pull it into my VMM server. You can see that I also have the network site. The external LND network site that I had also defined in my Nexus 1000 is also available. And I also have a VM network that's available that I can now even go and create a VM network based off of that one that was created in the Nexus 1000. I can do that up here. If I go up to VMs and services, create VM network. I just call it ABC. Select my logical network that I imported from the Nexus. And you can see here now I can select that external VM network that came from my Nexus 1000. And so the Nexus implements the isolation for this VM network. I simply connect the VMs now to this VM network that I've created, and it's available for use by my VMs. So let's go back to the networking view. So now I've imported my Nexus 1000. I've already gotten quite a bit of use out of it just from the fabric network elements that I've imported from it. But really what I want to do with it is I want to create a logical switch so that I have all my settings in a central place. So I'm going to do that by doing create logical switch. Oh, before I do that, though, let me just show you. As I mentioned before, the switch has a number of native settings available on it. And you can define those through a native port profile. You have two different types. You have a native uplink port profile that defines what logical networks will exist on the uplink. So if you remember at the beginning, I went into the physical adapter and manually selected that logical network that I wanted to use for that physical adapter. Well, I can define that now in a central place within my port profile, so that now whenever I apply this port profile to a physical adapter, it'll get connected to that logical network automatically. I also have a number of virtual adapter port profiles available. Let me create one of those. Create a native port profile, virtual network adapter port profile. Oh, I have to give it a name. I'll just call this TechEd. Or I could call it actually, it'd be good to name it something meaningful like SQL or actually iSCSI. So this would be for my iSCSI traffic, for example. If you have hardware that supports a number of different types of offloads available, you can select which of those offloads you want to use for network optimizations. You can select the security settings that we have available on the native switch, such as whether you want to allow MAC spoofing, DHCP guard. My iSCSI ports generally don't need DHCP. Router guard drops some router advertisements. If you want to allow guest teaming and IEEE priority tagging, you can select all those if you want. And then bandwidth setting. What are the minimum bandwidth settings that you want to have available? If you have 0, then there's no minimum defined. There are two options here available. You can do relative bandwidth by weight, or you can stay an explicit minimum and maximum. And which one gets selected used will depend on how this logical switch was initially configured. All right, so let's finish this native port profile. So there we go. Now we have this iSCSI native virtual adapter port profile. So now let's create the logical switch. So we'll be able to use that now in this logical switch. This is for my Contoso data center. Actually, I'll call it my TechEd data center. And now I can select which extensions I want to use on this for this logical switch. So I'm going to select SFlow and my Nexus 1000. And one thing that we'll do by selecting these, you're essentially saying that you want these extensions to be used on whatever host you apply this logical switch to. Now, these extensions have to actually get installed on the host, and VMM will do that automatically. When you install the provider, we require the vendor to make the MSI for those extensions available on the VMM server so that VMM can copy that MSI to the host and automatically install the extension so it's there to be configured by VMM. You don't need to go out to the host and do it manually on each host. Go through, we select which host groups you want this switch to be available on. Define our uplink port profile sets. And here we're saying on the Nexus 1000, we want to use this Nexus uplink port profile. With these port profiles in the Nexus, you can define also additional properties that can get displayed here. I didn't define any, but they will show up here. So there's additional information that you can show that says what this port profile means. I'm also going to select my native port profile as well. So this defines my logical network connectivity as well. So I can define multiple of these. And I can also define my virtual ports. Now, for defining your virtual ports, you're really defining what classification you want this logical switch to implement. You can select the predefined ones. They're global to your VMM server. So I want my gold classification to be available. Or I can create a new one. So I actually want to create a new one for my iSCSI ports. So I want iSCSI. So I created an iSCSI classification. This will now be available for any logical switch that wants to implement it. So I'm going to say for my Nexus 1000, I'm going to use this Nexus 1K virtual port profile. And I'm going to say that for my native settings, I want to use my iSCSI port profile. So now when I say I want to use the iSCSI classification for this VM and I deploy it onto this switch, I'll automatically get the settings for the Nexus 1K virtual port profile and my iSCSI settings for my native settings. Next, and then I finish it. So now I've created the logical switch. It's up here, my TechEd data center switch. Now I'm going to go and actually apply it to a host. So you can manually go and apply it to a host. We'll also let you automatically apply it based on when we do OS deployment. You can say in your host profile that I want this switch to automatically get applied to the host. But of course, you have the ability to do it manually as well. I'm going to go to my virtual switch section. I can say for each of my adapters, I can tell it I want to connect to this logical switch, and you select which uplink port profile you want to use. So now I'm saying this logical switch is now available on this host, and I want to have these settings for this adapter. And when we do that, the job is going to go, it's going to run. We're going to copy the extensions out there if they aren't already there. Oop, there we go. We'll install it, we'll configure it, and we'll make it available now so that when I deploy a VM, I can now just select the classifications that I want to use for the VM port. So just quickly go through. Now on my network adapter, I can say I want to connect it. Here's the VM network that I imported. And then I can also say I want this classification. It's the one that I just created. And that's it. Now when I deploy this VM, it's going to connect it to the ABC VM network that I created. And I'm going to get these settings for the port. And that's really all there is to using it. Let me cancel out of that. OK, switch back to my slides for just a second. All right, so the last thing I want to talk about is IP address management. There's a new server role in Windows Server 2012 for IP address management. And we felt it was important to be able to report the utilization from VMM into IPAM so that you have a central place where you can see your utilization not just from VMM, but from your DHCP servers in your environment or any other source that's able to report into IPAM. So in order to do that, we include on our CD layout, this is available in our CTP2 release, an IPAM integration script. And what it does is it basically, you can run it manually if you want, on demand. You can run this script, and it'll basically take all of the IP pools that we have in VMM, whether it's for a logical network or for a VM network, and report it into the Windows Server IPAM role. So let me show you that real quick. And then you can use all the reporting capabilities that are available in IPAM. So here is my VMM server. I'm going to open up a PowerShell window here. Let's see. And I'm going to go to, actually not that PowerShell window. Open up this PowerShell window for VMM. It's loading the VMM PowerShell commandlets. And on my desktop, I've copied my CD layout. And if you look, there's a scripts folder in here. And the scripts folder contains the IPAM integration scripts. You have to do what's called .sourcing to load it. It's going to load it. I don't want to update my help right now. So it's going to run, gives you the help to show you how to use it, and now it's ready to use. So now all I have to do is type invoke IPAM integration. I tell it which server I want to report to. In this case, HVH01. And before I do that, let me switch over and show you that there is nothing on that IPAM server to start. So you can see IPAM server, no addresses. It's empty, so let's switch back to my other. Let's run this. When I run that, it just asks me to make sure I really want to do this. I can do -4 if I want to skip the confirmation. And it's going now querying the VM server, taking all that information and importing it into, you can see it's already pulling in the TechEd VM network that I created, an IP pool for that. I can go back to my IPAM server right here, and I do refresh. And you can see now it's already starting to pull in all these VM networks for both the fabric. Here, the LN ones are for my logical networks and my VM networks as well. So I immediately get reporting. I can see if they're overutilized or underutilized, where they're OpenRel apping addresses, and how they're all configured. So it's a great tool that we have available. It also has the ability, you can run it as a scheduled task. So if you want to run it once a day, so that every morning when you come in and you drink your giant cup of coffee, you can look at your address utilization from the day before. So that's the recap. Logical networks define physical connectivity. VM networks are for your VM connectivity. Logical switches, port capabilities. So all of these sessions have actually already occurred. So if you want to go back and watch these online, I encourage you to do so. If you want to learn more about some of the other areas in VMM, please go back and watch those. And with that, I will close out TechEd for this year. So thanks, everyone, for coming. Appreciate it. If you have any questions, I have time to take those.